Welcome to ClickMyProject.com. Now we are going to discuss about learning latent representation for IoT anomaly detection. IoT is Internet of Things, network communication between smart devices. Latent representation is hidden features. The device hidden features. Learning is like using ML technique. Next, abstract. This is our project abstract. Internet of Things has emerged as a cutting edge technology that is changing human life. The rapid and widespread application of IoT. IoT Anomaly Detection System based on the analysis of IoT network features. First, we use an autoencoder network to gather later representation of the input data. This is followed by a classifier to identify whether an IoT network is anomaly or not anomaly. This proves that autoencoder network can compress the IoT network features and keep only the most meaningful features. The model later representation and classifies IoT anomaly detection high performance. Specifically, we developed 3 regularized version of autoencoder to learn a latent representation from the input data. The bottleneck layers of these regularized AI is trained in a supervised manner using normal data. Unknown IoT attack will then be used as a new input features for classification algorithms to evaluate the performance using machine learning support vector machine algorithm. Our proposed algorithm decision tree classifier with high accuracy prediction of network attack detection. Next, flow diagram. Start our program. Select and load dataset. Select and load network anomaly detection dataset. Data pre-processing. Data pre-processing is clean the dataset to check the null values. If you have any null values, replace with 0. Label encoding. Label encoding is to convert categorical data to numerical values. Autoencoding. Autoencoding is neural network process. Have input, hidden layers and output. That's purpose is dimension reduction. To find out the best data sets of the given data. Data splitting. Data is splitted into training and testing data. Algorithm implementation. Support vector machine and decision tree. Prediction and then report generation. Okay, next we are going to discuss about output explanation. This is our data set, anomaly detection data set. First, select data set. Next, data pre-processing. Data pre-processing is checking null values. No null values are there. Going to next process. Removing unwanted column. If you have any unwanted column, just remove it. Label encoding. Label encoding is to convert categorical values to numerical values. Next, data splitting. Data is splitted into X label dataset and Y label dataset. Next, autoencoding. Autoencoding is dimension reduction process to select in our data set to best values. Data splitting. Data is splitted into training and testing data. Algorithm implementation. Support vector machine algorithm gives 94% accuracy, and then classification report. MAE, mean absolute error, mean square error, root mean square error, root squared. Next, decision tree classifier. This is our proposed algorithm. Give 98% accuracy. Decision trees classification report. Mean absolute error, mean squared error, root mean squared error, root squared. Next, prediction status. Given data is normal. Comparison graph. Support vector machine, decision tree classifier.